So in this video, we're going to look at grams mole conversions. All right, so basically converting between grams and moles of substances. Okay. All right, so let's kind of just look at the idea of molar masses. Remember, molar mass is the mass of 1 mole of a substance. All right. Or we could say that molar mass is the mass of 6.022 times 10 to the 23 of any substance, really. Or molar mass is the molecular weight in grams, which we find the molecular weight from the atomic weights of the periodic table. Okay, and so with those numbers, all of these are equivalent to molar masses. All right. Now, what we can do is that if we know the amount of grams of substance of something that we have, then we convert that number. We could convert that number using the molar mass as a conversion factor to moles, and vice versa. All right. So if you know the amount of moles of something, you want to figure out what's the grams, then we could use the molar mass as a conversion factor. All right. So let's jump into this, right? So let's just say that I have 0.25 moles of H2O, okay? And I want to know, what is this in grams of H2O, right? As I said, we could use the molar mass of water as a conversion factor, okay? So we know that hydrogen. So let's pull up a periodic table. Let's not assume. Let's look at this. All right, so that we could go through the step-by-step process of figuring this whole thing out. All right, so let's look at hydrogen. Hydrogen, we see that its molar mass is 1.008. Okay, and so kind of put this periodic table off to the side here. So hydrogen, 1.008 grams per mole, but we see that we got 2 of them, so I'm gonna multiply this number by 2. Okay, and so in this case, my number is 2.016 grams per mole, and that's my total molar mass of hydrogen. And oxygen, so let's look at this periodic table here. We see oxygen, all right, has this is the molar mass of oxygen, which is 15.999. All right, so let's put this away. Okay, so 15.999 grams per mole. All right, and so just since there's only one of them, all right, and so now what we're going to do, we're going to add up these two numbers, and so that way we know what is the molar mass of our water molecule. All right, and so when we do that, 2.016 plus 15.999, all right, we get that the molar mass of water is 18. I don't know why I keep on doing that. 18.015 grams per mole. So that's the molar mass of water. All right, and as I said, we will use this, all right, as a conversion factor, so that way we could use this as a conversion factor so that we could get ourselves from moles of water to grams of water. Okay, now what conversion factors can we make from this, from the molar mass? Okay, now if you recall, so if you remember from going through dimensional analysis, we kind of did this videos ago. So if you need a refresher, go back and look at that video of dimensional analysis. But our conversion factors, we could make basically 2 conversion factors from this here. All right, we could either say that's 18.015 grams per 1 mole of H2O, all right, the mass of H2O, or we could have 1 mole of H2O over 18.015 grams of H2O. All right, now which one you use, it really depends on the problem. Okay, so let's set this up, and then hopefully when you set it up, you could easily see what we're supposed to do. All right, so we'll start off with 0.25 moles of H2O. All right, and I want to know what's the mass of this. All right, so now when I'm looking at this, it's okay, which of these conversions will help me get me from moles to grams? All right, and the way that you will figure this out is use the units as a guide to help you out. All right, what you don't want anymore is you don't want moles of water anymore. You want to cancel that out. All right. And so when we're looking at this is technically a numerator, right? And so if we want to cancel out the moles of H2O, we need to have moles of H2O in the denominator here so that it could cancel out. All right. And so then that means my mole of H2O will go on the bottom, and we're going to grams of H2O on top. So the conversion we're going to use is this one here. So I'm going to apply these numbers, all right? 18.015 grams divided by 1 mole, all right? This is going to cancel out the moles of H2O, and I'll be left with the unit that I am looking for, okay? And so all you have to do is just really plug this into the calculator. Is 0.25 times 18.015, all right, and we hit the equal sign. And so when we do that, we get that our answer is 4.5 grams of H2O. Now make sure you follow sig figs. This number, the number that you start with, is what sets the number sig figs your answer is going to have. All right, so in this case, since it's 2 sig figs, our answer is going to have 2 sig figs. All right, and so the answer to this question, if you have 0.25 moles of water, it's going to have the mass of 4.5 grams of water. All right, so let's look at another example. All right, let's go the other direction. So let's say that we have 4.65 grams of NaCl, sodium chloride, salt, table salt, right? And we want to convert this to moles of table salt, all right? So how do we do this? All right, well, so as I said, what you want to do is that you want to look at a periodic table, and that way you could look at the average atomic masses or the atom atomic weights of each of these atoms, which is your molar mass, and then we add them up to get our molar mass of sodium chloride. So here's our periodic table, right? And we see that the molar mass of sodium, all right, is here, which is 22.990. All right, so let's go ahead and let's write that. So sodium is 22.990 grams per mole. And then we're going to look for chlorine, and we see that chlorine, which is on the other side of the periodic table. All right, and it's 35.453 grams per mole. So let's go ahead and put this away. All right, and so 35.453 grams per mole. And then we're going to take the sum of these so that we can figure out what is the sum of sodium chloride. And so that when we put this into the calculator, all right, what we find is that 22.99 plus 35.453, we get that the molar mass of sodium chloride is 58.443 grams per mole. Okay, so now let's go ahead and start this off. So we see that we have 4.65 grams of NaCl. All right, so let's go ahead and convert this. Since this is grams of NaCl and that's a numerator, you want grams of NaCl as a denominator. We're going to moles, so I'm going to put moles of NaCl on top. All right, and so using this and putting the numbers where they belong, we will have 58.443 on the bottom, 1 on the top. We'll notice that grams of NaCl will cancel out. Get used to writing units, all right? It's amazing that, you know, when you're watching professors or teachers or experts doing these calculations versus students, we tend to find, there's actually a study on this, we tend to find that experts, teachers, professors always write their units during the calculations, and the students tend to try to skip them. All right, they don't usually write their unit, and that oftentimes is a source of error, because if you don't write your unit, sometimes you don't have that safeguard to help you catch your mistakes. All right, and so writing units will help you see, okay, what's supposed to cancel? What am I looking for? And hopefully you're asking these questions as you're going through these calculations. Okay, So, anyways, grams of NaCl will cancel out, and we're left with moles of NaCl. So in your calculator, you're going to put 4.65 times 1 divided by 58.443. You hit the equal sign, and when you do that, as I said, we put this in the calculator accordingly, and right now I'm about to put in my calculator. So 4.65, and essentially I'm just going to really divide this by 58.443. All right, and I get that my moles is 0.0796 moles of NaCl. All right, so this is the amount of moles that I have in this particular example. All right, so let's look at another example. We'll go a little bit harder in this one. All right, so let's consider sodium hydrogen phosphate, right? So this is sodium hydrogen phosphate. Okay, sodium hydrogen phosphate is basically it's a laxative. All right, and the maximum dose that is typically recommended per day is 3.8 grams. Okay, now a couple of things I want to know. I want to know how many moles of sodium hydrogen phosphate is in 3.8 grams. I want to know how many moles of the sodium ions we have in 3.8 grams of sodium hydrogen phosphate. And then what is the total ions that we have in 3.8 grams? Okay, so this is a three-part question, and I'll show you exactly how to think through this. And all of it is just really dimension analysis and just understanding the relationship. Okay, and so let's go ahead and let's tackle the first one here. All right, figuring out what is the number of moles of sodium hydrogen phosphate. Okay, and so what you're going to do is that you're going to go to the periodic table, right, and you're going to look at both the sodiums, the hydrogens, and the phosphate to figure out what is the molar mass. All right, and so since we've been doing this for a little bit, I'm just going to kind of go ahead and skip and figure out the number, but feel free, go ahead, pause the video, try to calculate what's the molar mass, and then unpause, and we'll just kind of take it from there. But anyways, so we find that the molar mass of sodium hydrogen phosphate is 141.954 grams per mole. Okay, so that's looking at sodium, the molar mass sodium, the molar mass hydrogen, the molar mass of phosphorus, and molar mass of all the oxygens, all four of them, and you add them up. Okay, so it's 141.954 grams per mole. Okay, so we're going to start off with 3.8 grams. So 3.8 grams of Na2HPO4, and we want to convert this to moles. So I'm going to have moles of this on top. All right, and then the grams of this on the bottom. Okay, and then we're going to put our numbers accordingly. So we know that the number is always 1 mole of something over the molar mass is 141.954. All right, and then when we put this in the calculator accordingly, all right, we find that the answer to this question, to the first question, is 0.027 moles of Na2HPO4. So that's how many moles of sodium hydrogen phosphate we have if it's 3.8 grams. Okay, now let's go ahead and answer the second question. How many moles of sodium ions we have? Now let's kind of think of this. Okay, how we could kind of figure, okay, how do I figure out the moles of sodium ions in this molecule? Okay, now if you look at this molecule or this compound of Na2HPO4, right? And so let's kind of set up a relationship. So for every, I don't know why I keep on doing this. For every 1 mole of Na2HPO4, how many moles of sodium ions I have? Well, let's look at this molecule. For every 1 molecule, how many sodiums are there? Well, we see that there are 2 sodiums. So I would say there are 2 moles of Na plus. Okay, and hopefully that kind of makes sense if you kind of think about this. Let me kind of give you like a kind of non-chemistry example of this same idea. So let's just say that you have a dozen smiley faces, right? Dozen emojis. This is my, actually for the sake of time and patience, a half a dozen emojis, smiley face emojis. All right, so I have 6. So I have a half a dozen smiley face emojis, okay? And if I ask you, okay, if I have a half a dozen smiley face emojis, how many eyes do I have? Well, you're thinking, it's like, well, there's 12 eyes. Why is that the case? Well, for each emoji, you got 2 eyes, right? So for each emoji, there are 2 eyes. And if I want to know the total number of eyes I have, well, then if I have a half a dozen, which is 6, okay, and so each one has 2, well, then 6 times 2, I have 12 eyes, okay? Same idea. Remember, mole is just a number. So if I have 1 mole of sodium hydrogen phosphate, and I want to know how many sodium ions I have, well, per 1 mole of sodium hydrogen phosphate, per 1 mole, there are 2 sodiums. All right, so 2 moles of sodiums. And that's how we could kind of come up with this idea. Okay, and so now knowing that, we could use this as a conversion to figure out how many moles of sodium ions we have. So what do we start with? Well, we know how many moles of sodium hydrogen phosphate we have in 3.8 grams, right? We figured that part out. All right, so I know that I have 0.027 moles of Na2HPO4, okay? And so my conversion, all right, and we have moles of Na2HPO4. I don't want moles of NH2PO4. I want moles of Na plus, okay? And then so I'm going to convert that from moles of Na2HPO4. What's the relationship between the two? Well, for every 1 mole of Na2HPO4, 1, I have, actually I'm going to write this in white. In 1, I have 2 moles of Na of the sodium ion, okay? And so when you multiply these numbers together, 0.27 times 2, we get 0.054 moles of Na plus, of sodium ions, okay? So that's how we figure this out. Now, the last question I ask is, what's the amount of moles of total of all the ions? Okay, and so let's kind of think about this. Like, how do we figure out how many ions I have? Well, let's look at once again our formula here. So what do we have in Na2HPO4? HPO4 is a polyatomic ion, so that's 1 ion. All right, so it has a 2 negative charge. Okay, and then we have 2 sodium ions. And so if we look at the total, we have a total of 3 ions. And that is our relationship. So we could say that we have, for every 1 mole of Na2HPO4 is equal to 3 total ions. Because essentially that's what we're looking for. 3 total ions. So let's go ahead and set this up accordingly. All right. And so we know how many moles of the sodium hydrogen phosphate that we have. So that we will say is 0.027 moles of sodium hydrogen phosphate. Okay. And then we're going to multiply this by what we're looking for. We're looking for total ions, and we're coming from moles of Na2HPO4. Okay, and then we will write these numbers accordingly. So 3 total ions, 1 mole of this. What does that equal? Well, it will equal 0.081 moles of total ions. All right, and so this is the way we will actually answer these questions.